This is just a pre-video reminder to say I want you guys to be taking notes on this section. I want you also to write down all the examples and the work, and then upload all of your work to Schoology for your accountability assessment. Okay. Hey class, so today we're talking about Objective 1 of Chapter 6.5, and this objective covers the four families of special angles. So last section, we talked about special right triangles, and we used the angles within those special right triangles, so pi over 3, pi over 4, and pi over 6. We used these in order to find values of our trig functions. And in this section, we're basically going to be doing the same thing, but we want to extend the amount of angles that we can cover. So pi over 6, pi over 4, and pi over 3, if you look at the xy plane, I'll just draw the first quadrant for now because that's all we can all we really care about right now. Pi over 3 was, let me think, no, pi over 3 was like this. Pi over 4 was more kind of in the middle, and pi over 6 was close to the x-axis. So we found sine, cosine, all the trig function values for each of these angles right here. But this only covers the quadrant 1. So we're going to take these angles and we're going to rotate them until they're in quadrant 2, 3, and 4, and we're going to make a family of angles out of them. And this is important because it gives us an easy way to figure out the values of the trig functions given one of the members of these families. Okay. The first family that we're going to talk about is the family of angles that we kind of ignored in the last section when we were doing special right triangles. So remember that whenever we were dealing with some special right triangle, if it was the pi over 4, we were mostly concerned with these two angles. And we never really talked about sine, cosine, and tangent of these right angles. But here in this chapter, we're going to start getting into what those values are going to be, and we're going to talk more about that in Objective 3. For right now, all you need to know is that this is the first family, and the only requirement of these is that the angles are coterminal with one of its members. So angles belonging to the quadrants family must be coterminal with 0, pi over 2, pi, or 3 pi over 2. And in this figure, which is in your e-text, you can see the degree measure as well. So this is also the family of 0 degrees, 90 degrees, 180, and 270. Okay, on to the next family. Okay, the next family is the pi over 3 family. And here we have the set of its members, pi over 3, 2 pi over 3, 4 pi over 3, and 5 pi over 3. Again, in the figure, you can see the degree measures of all of these angles are 60, 120, 240, and 300. So in order to be a member of the family pi over 3, again, angles have to be coterminal with one of these members. And something that we'll go over when we talk about the examples is an easy way to tell if some random integer times pi over 3 is coterminal with it is whether or not that integer is divisible by 3. But again, I'll talk more about that when we talk about examples at the end of this. But for now, let's talk about the next family. And here we have our second to last family, pi over 4. And I actually just noticed the typo in this. If you look at the angles that it's or the degree measure of all of these angles, this first part of the figure says 315, but it's actually 45 is the first angle in degree measure, and then the next one is 135, 225, and 315. So this is the pi over 4 family of angles, and again, to be a member, they have to be coterminal, and they can't be basically divisible by the bottom number 4. So on to the next family. Our last family is going to be the pi over 6 family, whose members are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. And again, I can write these out for you. The degree measures of these are going to be 30, 150, 210, and 330. So now that we've defined all of these families of angles, let's go through an example and try to see if we can tell what family a random angle belongs in, or belongs to. Okay, so here's an example of an angle you may be given, and the question might read something like, determine the family of angles to which it belongs, sketch the angle, and then determine the angle of least non-negative measure, theta c, that is coterminal with the given angle. And the first step in my mind, or in my eyes, is to look at this 35 and ask yourself if it's divisible by 6. And the answer to that is no, it's not divisible by 6. So that would lean me personally towards the idea that, okay, maybe this angle is part of the pi over 6 family. But to know that for sure, we have to use our coterminal angle formula. And what we want to do first is actually the last thing the question might suggest, which is find the least non-negative measure that is coterminal with it. So the reason why we want to do that is because when we find that least non-negative measured angle, uh, we will know which family this angle is a part of. And let me just show you that, and maybe that'll make more sense. So we're going to write our coterminal angle formula right here. And we want to ask ourselves, again, how much do we have to increase k until we get this negative angle to be positive? And it might help if we write 2 pi in terms of this 1 over 6 fraction. So if we write 12 pi over 6, maybe easier to see that this k is 3. Because when we multiply k by 3, or 12 by 3, we get 36. And 35 plus 36 is just 1. So the least non-negative coterminal angle is pi over 6. And it looks like my guess was right. It is part of the pi over 6 angle family. Now, as far as sketching this, let me scoot this screen over a little bit. So if we look at the xy plane, remember on the first part of this video when I talked about where pi over 6 was, pi over 6 was the angle closer to the x-axis. And we want to draw our angle in with a circular arrow, as you've seen before, like this. And so since k is 3, that means it'll make 3 full rotations. So we pass this arrow line 3 times. So that's 1 full rotation, 2 full rotations, and then 3 rotations. Is that correct? Yeah. So this right here is going to be our negative 35 pi over 6 angle. That's how you tackle one of these problems. Okay, so here's a second example, but this time our angle is in degrees rather than radians. So we're going to try to do the same thing. We're going to try to figure out which family of angles this angle belongs to. We're going to try to graph it, and then we're also going to try to find the least non-negative coterminal angle of this angle. So when it's in degrees, I don't really have a way of looking at this and knowing what family it belongs to. So I'm just going to start this example by looking at the coterminal angle formula. So we write 1,110 degrees minus, instead of 2 pi, because this is in degrees, so I should put plus, 360 degrees times k. Okay, and now again we want to look at how much do we have to make k in order to make this 1,110 be in the range from 0 to 360. So you can kind of use your calculator, or you can just look at it and try to guesstimate. When it turns out that this k is going to be negative 3. So when we multiply 360 by negative 3, we get 1,110 minus 1080. This is going to equal then 30 degrees. So our least non-negative coterminal angle is 30 degrees. And again, 30 degrees, if we multiply that by pi over 180, or if you just remember what 30 degrees is, we see that this is pi over 6. So this belongs to the pi over 6 family as well. Okay, so now we want to draw this angle just like we did the last one. So we draw our xy plane. Oops, sorry. XY plane, and since this is a pi over 6 triangle, again, we're going to be looking at the angle that's really close to the x-axis. And our rotation is going to be shown by a circular arrow again, except this time it's positive, so we go in the counterclockwise direction instead of clockwise. So we start right here. Since k is -3, we go 1, 2, 3. And that is going to be how we draw our angle. Sorry, the starting position should be here. Okay, so that's objective 1 of 6.5, and we've gone over 2 examples of how to find what family some random theta is in, find its least non-negative coterminal angle, as well as give it a graph right here. And that's all. Hope you guys have a good one, and I'll see you next time.